Hello everybody, welcome to our video tutorials. In this video we will show you how to do load shedding application using flexible limits in EasyGen 3000 XT series. Let's start with quick description of what load shedding is. Load shedding ensures the availability of power for critical loads by disconnecting less critical ones by clear defined rules until sufficient power is established. Thanks to that, we are sure that the generator will not be overloaded and our most important loads will be alive. We use load shedding in these typical scenarios. The consumer load increases faster than generators can be added. The consumer load increases, but no generator can be added anymore. A generator failure must be compensated until a new generator has been added. In this video, we will show you an use case with two load shedding points working in one generator as an example. Okay, let's see how to configure load shedding. We will use flexible limits 25 and 26, as they have parameter called fallback time, which defines the time to reconnect the field if the load has decreased. Flexible limit 25 will be the first load shed point. We turn the monitoring on, and leave it at overrun. A source at both limits generator active power. The limit defines the load to shed the field, in this example 95%. The hysteresis defines the threshold for the reconnection of the field, if load has decreased or the rated power has increased by an additional engine. The delay defines the priority of load shedding. The less critical field must be configured with the shortest time, the more critical fields with longer times. The fallback time defines the time to reconnect the field, if the load has decreased. The alarm class of the examples is configured as Class A to indicate the load shedding, but not cause any additional action. The acknowledge is always set to self-acknowledge. Okay, now we set the second flexible limit, but with different switching points. So, the first load shed point will be activated if we have load over 95% for 0.1 seconds. If the load is still over 95% for 0.4 seconds, the second load shed point will be activated. If load decreases by 10% from 94 to 84%, this is 11% of the threshold and higher than the hysteresis. The fallback timers are starting. After 2 seconds, field 2 will be connected and after 3 seconds, field 1 will be connected. Of course, we need to assign our flexible limits to proper discrete outputs, which will disconnect and connect our fields. In this example we will use discrete output 11 and 12. Here we have our simulation tool. You can see right now I have one generator connected. I have some load connected here. And we are parallel to mains. EasyGen is sharing the load with mains. Now I will increase the load, so the generator active power will rise above 95%. This will activate our flexible limits connected to load shed outputs. As you can see, both were activated. Now I will decrease the load to see the flexible limits deactivate. And this is how the load shedding can be achieved with our EasyGen units. This is all about the load shedding. I hope you enjoyed our video. Make sure to check our other training videos as well.